On the planet Venus, Russian space agency has claimed Russia's ownership of Venus.
Of the planet Venus that is leading some scientists to believe that there could actually be life on that.
When the Soviet Union's Venera program successfully transmitted unprecedented data from the surface of Venus, it didn't merely mark a victory in planetary exploration. It ignited a seismic tremor across the global scientific community, especially within the United States. The revelation was nothing short of earth-shattering. American scientists, though aware of the USSR's progress in Venusian exploration, had not anticipated the scope and depth of the Soviet findings. This wasn't just a collection of dry data points from a distant planet. It was an extraordinary confirmation that the second planet from the Sun was far stranger and more hostile than previously imagined. Before we start, smash the like and subscribe buttons for more updates. The mission that delivered this blow was Venera 13, launched in 1981 and touching down in 1982. While prior Soviet missions had made Venus the first planet other than Earth to be visited by a human-made object, it was Venera 13 that truly cracked open the veil of mystery. The spacecraft survived for over 2 hours in Venus's punishing environment, longer than any had dared to hope, and it delivered not just telemetry and temperature readings, but vivid color images, chemical analyses of soil samples, and acoustic recordings of the Venusian wind. These weren't mere curiosities. They were keys to understanding a planetary system that behaved according to rules utterly foreign to Earth's. The shock began with the atmospheric readings. The pressure at the landing site measured around 90 times that of Earth's sea level, equivalent to being nearly a kilometer under the ocean. The surface temperature hovered around 465 degrees Celsius, hot enough to melt lead. And yet the Soviet probe withstood these conditions, which American engineers had long considered nearly insurmountable. The very fact that the USSR had engineered a lander capable of operating in such extremes was a technical feat that forced NASA to reassess its assumptions, not only about Venus, but about Soviet capability in deep space exploration. But the real jolt came from the images and chemical data. For the first time in human history, we could see the surface of Venus not as an abstraction painted by telescopes or artists' renderings, but as it truly was. A desolate, rust-colored wasteland strewn with fractured rock plates under a thick, hazy sky. There were no signs of the ancient seas once hypothesized, no traces of vegetation or organic life, but rather a grim portrait of a world that had likely undergone a catastrophic transformation. Venus, once imagined by some early theorists as a sister planet to Earth, appeared now as a cautionary tale. Its skies were filled with carbon dioxide and sulfuric acid, creating a greenhouse effect so extreme that it rendered the planet inhospitable to any known form of life. The implications of this discovery reverberated through laboratories and academic halls in the United States. Prior to this, there had been competing models about the nature of Venus's atmosphere and geology, with some American scientists still holding out hope that the planet might possess temperate zones or even microbial life. Venera 13 demolished those ideas with hard data. The Venusian surface was dry, acidic, and baked under relentless heat. Soil analysis indicated a basaltic composition, similar to volcanic rock on Earth, suggesting a violent geological history marked by extensive lava flows. The density and composition of the atmosphere indicated not a planet slowly cooling and stabilizing, but one that had veered down a path of escalating thermal imbalance. For American scientists, particularly those in the planetary sciences and climatology communities, this was more than just a wake-up call. It was a paradigm shift. The data forced them to reconsider the theoretical boundaries of planetary evolution and climate modeling. Venus was no longer just a subject of curiosity. It had become a mirror through which Earth's own atmospheric fate could be glimpsed. The extreme greenhouse effect on Venus, clearly evident in the data, suggested that under the right or wrong conditions, even a planet once potentially habitable could spiral into a thermal death trap. This cast a shadow over assumptions about Earth's long-term climatic future and drew urgent comparisons to rising CO2 levels in our own atmosphere. Technologically, the Soviet success highlighted a painful gap. While the United States had focused extensively on the Moon and Mars, the Soviet Union had invested heavily in developing resilient, high-pressure landers that could survive Venus's crushing environment. The precision of their entry, descent, and landing systems, as well as the durability of their instruments, outpaced anything the US had attempted for Venus. The robust engineering and innovation required to keep a probe functional under such extreme heat and pressure were a testament to the Soviet Union's unrelenting push to conquer the challenges of space exploration, no matter how inhospitable the target. Within NASA, the ripple effect was immediate. Researchers began scouring the Soviet published results, seeking every shred of insight. The data reshaped the American approach to planetary missions. Suddenly, Venus was no longer a sidebar to Mars or the outer planets. It was a high-priority object of study in its own right. The idea that a nearby planet could serve as a dire example of runaway climate change galvanized both scientific inquiry and public interest. American climatologists began incorporating Venusian data into Earth climate models, looking for parallels that could inform predictions and preventive measures. Venera 13's success also influenced broader philosophical and scientific perspectives on habitability in the universe. The realization that two planets of similar size, mass, and general composition, Earth and Venus, could evolve in such radically different directions stirred a profound sense of cosmic humility. It punctured the assumption that Earth-like planets were inherently Earth-like in experience or fate. The Soviet data suggested that habitability was not just a matter of proximity to the Sun, but the result of delicate balances in atmosphere, geology, and perhaps even cosmic chance. The sensory data Venera 13 returned was especially haunting. The sound of Venus's wind, recorded and transmitted through layers of interference, offered an eerie, almost ghostly glimpse into a place so alien and unwelcoming. While the recordings were limited in fidelity and duration, they were enough to give American scientists an emotional as well as intellectual reaction to the alien world. This was not just a distant globe, it was a real dynamic place, howling with acidic winds and cloaked in permanent dusk. It was the realization of an atmosphere that actively crushed and incinerated anything that dared to touch its surface. Geologists and planetary scientists in the US marveled at the basaltic terrain revealed in the images. The fragmented slabs and unusual erosion patterns sparked debates over the geodynamic processes at play. Without plate tectonics like Earth's, how did Venus maintain its apparent geological youth? The implications were profound. Either Venus had a completely different system of heat transfer and geological renewal, or the planet underwent episodic global resurfacing events. Either way, it challenged Earth-centric assumptions about how rocky planets evolved and aged. Even the limitations of the Venera mission, its brief operational window, and the challenges of real-time data transfer through thick atmospheric interference underscored the formidable achievement it represented. American engineers had to acknowledge the extraordinary toughness of the Soviet-built systems. Every byte of data the lander sent before its inevitable destruction was invaluable, squeezed out of moments bought through meticulous engineering and an audacious vision. The knowledge that the USSR had quietly achieved this while Cold War tensions dominated international focus only deepened the sense of astonishment and begrudging respect. The scientific community in the United States was not merely shaken by the data itself, but by what it represented. That their Cold War adversary had penetrated one of the most hostile environments in the solar system and returned with revelations that would reshape planetary science. The Venera program became a benchmark for what was possible with determination, expertise, and a willingness to take technological risks. It became clear that Venus was no longer an ambiguous presence in the night sky. It had character, it had violence, it had stories buried in its superheated crust, and the Soviets were the first to listen. As the full scope of the Soviet data was absorbed, it began to filter into textbooks, conference talks, and even speculative fiction. Venus, once imagined as a cloud-covered paradise, was now a vivid warning. Scientists in the United States scrambled to recalibrate not just their Venus models, but their interplanetary priorities. Missions to study exoplanets took on new urgency, guided by the stark lesson that even the most Earth-like planets might be harboring infernos under their clouds. Venus became a symbol of scientific humility, a reminder that familiarity in appearance does not guarantee comfort in reality. American atmospheric scientists, too, took note. The efficiency with which Venus retained and amplified its internal and solar heat was deeply alarming. It showed how a thick, carbon-rich atmosphere could not only sustain but accelerate a planet's own destruction. It validated models that had warned of tipping points and positive feedback loops, where slight changes in atmospheric chemistry could trigger runaway heating. Venus had clearly crossed such a threshold in its past. The Soviet findings offered a real-world laboratory to study the mechanisms of that disaster. The data also revived interest in comparative planetology. By contrasting Venus with Earth and Mars, scientists were able to explore the full spectrum of terrestrial planet evolution. Venus, far from being a failed Earth, was a divergent Earth, one that began with similar building blocks but spiraled into an entirely different destiny. The Venera missions, and especially the success of Venera 13, brought that divergence into sharp relief. They forced American scientists to reckon with the fragility of Earth's own equilibrium and how easily it might have tipped the other way under slightly different initial conditions. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on Soviet Venus findings? What do you expect next? We want to hear from you. Thank you for watching and see you next time.